Alright, this is a video on J.J. Thomson and his cathode ray. The discovery of electrons is credited to J.J. Thomson, an English physicist. And what you need to know is how he was able to experiment with this glass tube with some metal discs and an electrical source to determine not only that there were electrons, but also what charge they were. So inside the glass tube was a couple metal discs, which we'll get into as far as saying cathode and anode, referring to them being negatively charged cathode and positively charged anode. And inside the tube was also some wire to connect to these cathodes and anodes, as well as a gas that was at low pressure. Now, the details as to how it works isn't important, but what is important is when a current was sent through this, because we can actually see if we make a little rectangle, if you include the little gray cathode, you kind of have a complete circuit. And what's happening is inside these this cathode ray are electrons. Now, what's happening is right now they're just going from negatively charged to positively charged, which right there would indicate that the electrons have some sort of charge because they're not just fixed within this gas tube. They're actually in a direction. Now, thing is, we didn't quite know, or nor did Thomson know, what direction the electrons were going in, because with this image as it was just a solid beam. So what he decided to do was introduce another cathode, or inside the cathode ray tube, you'd also have a little metal disc that was not charged, and it had a slit in it. And that slit was able to confine that beam, that cathode ray of electrons, and as it passed through the slit, it was able to go towards the anode. Now, what he did to determine that it was a negatively charged particle was he put a positively charged plate above and a negatively charged plate below, and just like we've been learning for many, many years now, that opposites attract and likes repel each other. So the fact that it went away from the negative plate and towards the positive plate indicated that this electron beam was negatively charged. So it was Thomson who discovered that, hey, electrons must have a negative charge to be attracted to that positive plate. Now, there's a couple things. He knew that, yeah, it was made up of, an atom was made up of electrons, and it had electrons, and it had a negative charge. But he also realized that if it was made of just negative charges, then all matter would have negatively charged. So he knew that, just based on intuition, that there must be a positive component to it that would neutralize out an atom. So he knew that an atom must be neutral, but it also contained these negatively charged particles, which we call electrons. But because it was neutraled out, there must be a positive component. And from that idea and the evidence from his cathode ray tube, he came up, along with Lord Kelvin, who is, yeah, that's the Kelvin guy from temperature, right? The two of them proposed this, what we call a plum pudding model. Okay, plum pudding model of an atom. So it was a spherical object, so it looks like Dalton's, but instead of being uniform, there are pockets of negatively charged particles, which we determine as electrons, and the rest of it must be positively charged in order to counteract the electron's negative charge. So Thomson's model, which is the plum pudding model, indicates a spherical object, which is the atom, an atom that's spherical, and inside there's little electrons throughout that are negatively charged, and then the rest of the atom, or the rest of the sphere, is positively charged, which would result in an overall neutral atom. Now, the reason why it's called the plum pudding model is because there was a pudding that has little plums in it, kind of like raisins, right? inside of a pudding, and it kind of the model that they described reminded them that of a dessert, which would be plum pudding. So that's what all these electrons are. They're representing the little raisins or plums within the pudding of positive charge.